Example 4 says, from a point on a level plain at the foot of a mountain, a surveyor finds the angle of elevation of the peak of the mountain to be 20 degrees. She walks 3,465 meters closer on a direct line between the first point and the base of the mountain and finds the angle of elevation to be 23 degrees. Estimate the height of the mountain to the nearest meter. All right, so it says on here that first she just looks up at the top of the mountain and the angle of elevation is 20 degrees, right? So she's looking at the mountain. Angle of elevation here is 20 degrees. Then she walks 3,465 meters closer. So she's going to come up to this point here. So this is our 3,465. And looks back up at the top of the mountain and finds the angle of elevation is now 23 degrees. And we're going to estimate the height of the mountain. So we're looking for that. So how can we find this? Okay, we can find all of our angles, right? Because it's the mountain. So at the peak, it's going to be straight up from the ground somewhere. So we're going from it. Okay? All right, well, I can find my little angles. What is this little angle right here? You know what? I'm going to, hold on a second. I'm going to redraw on a blank slide. Okay? So I can make it a little bigger so we can see it better. I have less empty slides than y'all because I went through and deleted, but I'd already made the copies for y'all, so I apologize. But it's better than handwriting it, right? I don't know what you're talking about. Okay, so it's a little bigger, it's a little neater looking, so makes it easier for us to read. So what did you tell me that top little angle was, 67? Yep. What about the other top little angle? Oh, well, I don't know yet. What about this angle beside the 23 degrees?
157.
Okay. And now the top little angle. All right. We're okay? We're good finding the angles? Now, remember, I didn't label it, but we're after this height over here, correct? The height of the mountain. So, well, if I could just look at the triangle I have there on the right. If I knew another side, then I could just use SOHCAHTOA, right? Because it's a right triangle. So I'm going to have to use a triangle on the left there to help me somehow find another side. So how can I use that little triangle to find, well, what side do they have in common? I guess I should figure out first. Yeah, the one that's right there in the middle of them, right? So let's call this, what, an X, side X. So that would be this side here, which is also this side here. Can I solve for X using that little triangle at the bottom there? Possibly it's not a right triangle, so the only option we have is the law of sines. So the question is, do I know an angle and the side opposite from it? I do, don't I? I know the 3 degrees and I know the side opposite of it. So we can say the sine of 3 degrees over its side opposite equals, well, I'm after side x, so what is the angle across from it? Across from the x? The 20 degrees. So cross multiply and divide. And what are we getting for x?
22,644.
All right. So now that I know that side there, how can I find h?
Use the 90 degrees.
I can use SOHCAHTOA. Am I going to use sine, cosine, or tangent?
Does the other thing work still? On the 90 degrees?
I think so, yeah. I think so. Well, it depends on what angle we're going to use. Let's say we use the 23 degrees. What is the 22,644? What side is that to my 23 degrees? It's across from the 90. Hypotenuse, right? The 22,644 is across from the 90, so that across from the 90 is always hypotenuse. What is the h? Opposite. So which one is opposite over hypotenuse? Sine. So we could say here that sine of our angle equals opposite over hypotenuse. And then just multiply by the denominator, right? So we'll find that h is equal to 22,644 times sine of 23 degrees.
8,847.
And what was our units? Meters. So that mountain is 8,847 meters tall.